Jen, right? Jen. Okay. Brenda. Okay. Jacqueline. Okay. Leaf, yes. Daniela. Yes. Okay. Yvonne. Okay. Jasmine. Yes. Okay. Uh, Haley, no. Jara, yes. Christian, no. No, Aiden. Cynthia and Nadia. Okay. Najma. Rocio, yes. All right. 53. Okay. All right, ladies and gentlemen. Today we've got a few things to get done. We're going to give you some time. Some of you have already started turning it in. That is fine. But we'll make sure that you have everything you need to finish that Alka-Seltzer lab. If you turned it in and for some reason you need it back because of something we discussed or something we talk about today, I'll be more than happy to give it back to you. We're going to finish reviewing the vocabulary for the unit, and that is because on Friday you will have a quiz on the vocabulary. Okay? And then today you're going to have a safety quiz. Now, don't panic about the safety quiz. You take it as many times as you need to until you get 100%. Okay? There's only 15 questions, and most of the questions are common sense. So I'm not going to ask you about, like, where is the fire extinguisher located in the room or things like that. It'll be more basic questions. And you'll see that today. Put away your phone. Remember, put away your phone, put away your headphones, put away your electronics, ladies and gentlemen. Not on your desk, not where I could see them. Put away, please. Okay? Again, some of the things that they wanted us to remind you of is that is one of the things that is still our policy. They're reinforcing that this try to start out again with your electronics. They need to be put away bell to bell. Okay? They've told us that even there are some teachers who, if you go to use the bathroom, they make you leave your phone. Okay? I'm not that way, but again, if I see a phone, if I see electronics, I will ask you to put it away once, like I did at the start. And from there on out, you have two basic choices, which is you either put it in the box over there or you take it down to the office. Okay? So please keep that in mind. Questions, ladies and gentlemen? Okay. The first question, our question of the day is basically, do you have any questions about the lab we did yesterday? Is there anything about the lab that you have questions on? I think we got through most of it, ladies and gentlemen. We will double check here for a minute, but before we get going, are there any questions on it? Okay, I do want to show you something, ladies and gentlemen, and this is in Google Classroom. If you are ever missing on the day of a lab, ladies and gentlemen, I put the labs out in Google Classroom, but let's say you're absent on the day that we do a lab. I go into that lab, okay, which if you go into Google Classroom, your lab looks like this, ladies and gentlemen. But if you ever miss a day, what I do is I go into Google Classroom and I literally take that document out of your Google Classroom and I replace it with an alternate assignment, okay? So you did the Alka-Seltzer mini lab yesterday. This is the Alka-Seltzer alternate assignment. What this means, ladies and gentlemen, is if you miss a lab in my class, you don't have to worry about coming in and making it up with me sometime before school or after school or during home base or something like that, okay? I put an alternate assignment in there for you, okay? Now, for this one, ladies and gentlemen, again, based on the question above, write a possible hypothesis for this lab as an if-then statement. And then what I did, ladies and gentlemen, is I took pictures of the water, the Alka-Seltzer, and the 7-Up. And I put it into the lab for this person who wasn't here yesterday. And now you can make observations. I know it's a little bit harder because you can't feel these things, you can't smell them and things like that, but you can still make observations of these three things, okay? Based on what you're seeing in the pictures and things, okay? And then what I also did for them is here is a short video of the Alka-Seltzer and the water reacting together. So again, they can make the observations that you would have seen while you were here in class, okay? So if I can make videos of things, I've made videos of things for you, just so that you know, okay? And again, all this does is prevent you from having to come in and do the lab outside of class time, okay? So here's a video for the 7-Up and Alka-Seltzer. Excuse me, Mr. Brent. Yes. Okay, send in a smart pass for him. Okay, thanks. All right, bye. Jen, you need to go down to student services real quick, okay? Take your stuff. I don't know how long you're going to be, okay? So anyway, ladies and gentlemen, that's in there as well. And then I put in the data that you would have collected. So basically, everything that you would have done in the lab is here for you, which means you can now answer the questions. Now, I understand you weren't here for the day we did the lab. Maybe you have questions about some of the questions in the lab or something like that to finish completing it. Ask me before class, ask me during class. When we have work time, ask me after class. But the point is, I think this is a lot easier for you than me telling you, hey, you need to come in after school on Wednesday so we can redo this lab. Because the other thing, to be honest with you, I have 3 classes going right now, all of which use the lab space, so it's hard for me to leave things set up for you, okay? So I've gone to doing this to kind of helping you out if you ever miss a lab. So just so you understand, this would be in Google Classroom for you in the place of where the regular lab was. I don't make a special assignment for you. I just go in, I take out the other lab, and I put the new document in its place for you, okay? Now, again, you guys were all here yesterday. There should be no problem with that, but that's what I would do for you if you ever miss a lab. Questions on that? Okay. All right. So let's get back to this, ladies and gentlemen. We had gone down here, and we had gone through the question number 6, the 3 constants, okay? We were finishing up with qualitative and quantitative observations yesterday when the class ended. What's the difference between quantitative and qualitative again?
Quantitative has numbers, qualitative doesn't.
Okay, quantitative has numbers, qualitative doesn't. Okay? So in your lab, give me a qualitative observation that you might have made.
Liquid.
What about it?
That it's clear.
Okay. And you could say that it's a liquid, but I guess let's begin with the water is a liquid, okay? Or the 7-Up is a liquid. Being a state of matter is an observation about something. And then again, you get into talking about clear. Now, what does clear mean, ladies and gentlemen? Okay, now be careful, because you're taking away an observation if you use clear and transparent as the same thing. Now, to me, clear means there is no color to the liquid. Transparent means you can see through it, correct? So people always struggle and they say, well, I can't think of 3 things to describe water. It's a liquid, it's clear, and it is transparent. Transparent simply means that what? You can see through it. So the glass in the door is transparent. Now the lights above our head are not transparent, okay? You cannot see. We can see the light coming through it, but we can't see through those plastic pieces in the lights, can we? Does anyone know what that's called?
It's semi-transparent. So
Well, it's not, technically not tremor. It's what?
Translucent?
Yes, it's translucent. That's what that means. Translucent means light can pass through it, but you can't see through it. If you've ever been in a church and saw a stained glass window, the colorful stained glass windows, you could see an object outside that window. You could see its shadow through the glass, but you can't see that object clearly. Light can pass through that stained glass window. Light passes through these covers on our lights up above, but we can't see through them. That's translucent. Semi-transparent means you can kind of see through it. It's kind of in between. And then what would the ceiling tiles be?
opaque.
They're what is called opaque. So if you cannot see through something, that is opaque. Okay? If you try to see through a glass of milk, you're not going to see through the other side. Okay? That means that it is opaque. Okay? So again, I'm not saying you can't use the word clear, and some people would use it to describe the color. Some people would use it to describe that you can see through it. But again, if you're struggling for observations, you may want to separate those two. Okay? What about quantitative observations?
The times.
Okay, one more time, what was that?
The amount of water.
Okay, good. People forget that we did the amount of water, right? And even though it doesn't show up in your tables anywhere or things like that, that is still a quantitative observation, the amount of water. What was the other one, Miro?
Time.
The time. What else? The amount of tablets that we used. Okay? So again, sometimes those quantitative observations hide a little bit on us because there's something that was in the procedure or something that was in the instructions of what we did that help us get to there. Okay? So again, 3 examples of quantitative, 3 examples of qualitative. Yeah, go ahead. 3 examples of quantitative, 3 examples of qualitative observations. Again, if there's any others, but remember, this has to be a number. Has to be. So you can't say, well, the object was long. Yes, that's describing its size, but it's not an actual number. Okay? So keep that in mind. All right? Now, if you've done your conclusion and you're finished with this and you turn this in, absolutely fine. Not a problem at all. But I do want to point out something, and if you feel like you need yours back after we do this, I will be more than happy to do that. Write a conclusion answering the original question and use data from the lab to support or disprove your purpose statement. All right, let's go back up to our purpose statement, ladies and gentlemen. It was a long time ago, okay? To find out how changing the temperature of a liquid or type of a liquid determines how fast a reaction occurs, okay? So that is what we were trying to do. Now, hopefully, ladies and gentlemen, hopefully in here when we rank them, we had 3 different temperatures: hot, room temperature, and cold. Now, let's get one thing out of the way. What we expect to happen in a lab and what happens sometimes can be 2 different things, okay? Can be 2 very different things. So, when we think about this, ladies and gentlemen, and we are looking at this, if we talk about temperature changing, let me bring something up here just so that I stay on this screen, okay? All right. So when we talk about the temperature, now if we order the temperature, what I mean by that is there are 2 ways that the order can go. We can go cold, we can go room temp, and we can go hot, correct? Or we can flip it around, okay? Now, hopefully, in this case, our order, the temperature is increasing, going up, right? Now, hopefully, if we then look at time, ladies and gentlemen, hopefully when we look at time, the time should either be going up, meaning getting faster, or should be going down, meaning going slower. Now, it is possible, though, that there might not be a pattern. Now, the only way that happens is if room temperature is not somewhere in the middle. If room temperature is either the fastest or the slowest, then our lab at least proves that temperature doesn't matter. Okay? It proves that temperature does not matter. Okay? Now, I'm not saying that is what happened. Now, in reality, what should have happened is that as the temperature increases, the time should have gone what? Should have gone down. Time should have gone down. Now, I don't guarantee that that did, okay? But this is what you're going to answer in your conclusion, okay? You are going to tell me if there is a relationship between temperature and time. Now, again, I'm hoping it came out that way. But it is possible that it didn't, and there are a number of reasons, and we're not going to get into them. But if room temperature is not in between cold and hot, It means that temperature did not matter in this lab. Okay? That's what that means. It means temperature did not matter in this lab. So in our original statement, we were trying to see if temperature does make a difference in how fast something dissolves. So in your conclusion, ladies and gentlemen, down at the bottom, you need to tell me if temperature did affect how fast it dissolved. So when we increased the temperature, did it or did it not? Did it support or did it disprove what we were trying to say? Okay? And again, you are not going to be graded on if your results didn't work out. You are graded on if your conclusion matches what you found in your lab. So, your conclusion should go back and say something along the lines of, in this lab, we found that as temperature, you can use increased or decreased, I don't care which. The time increased, decreased, or had no effect on it. Those are the three options that you have. Either the time increased as it got hotter, either the time decreased as it got hotter, or the time didn't do either one. It didn't support the fact that temperature makes a difference. Now, this is the important part too. You need to use data. Data is numbers. So somewhere in there, you have to refer to the times. So you could say something like, the hot water dissolved in this many minutes, this many seconds, this time. And the cold water dissolved in this time. Now you have used data to support what you have told me. Okay? Now you have used data to support what you have told me. Okay? And if it doesn't make sense, you still need to use data to say that. Well, the hot water was 1 minute and 2 seconds. The cold water was 1 minute and 5 seconds. And the room temperature water was 1 minute and 30 seconds. Put numbers into your conclusion, please. Because that provides the evidence to support what you are saying. Questions? In your conclusions, ladies and gentlemen, this is the one part where you need to write true sentences in a short paragraph. But please understand, I'm not going to grade this on how much you put in this box. I just want you to definitely tell me, did temperature matter for how fast the Alka-Seltzer dissolved? And use some data to support that and tell me, hey, here is what the numbers were for hot, medium, cold. To support what you are telling me happened. Okay? Now there was a second part to our purpose, which was what? Okay? Now, if you have done that for temperature with your conclusion, I am fine with that. If you want to add a section about the type of liquid, well, we found that 7-Up dissolved faster than water with the time of this compared to this, you are welcome to do that as well. But if you don't, I will not downgrade you for it. As long as you tell me about time and temperature for the hot, the cold, and the room temperature water. Okay? As long as you give me that, ladies and gentlemen. If you're done with this and you have finished this, please turn that in. Again, if you're finished with this, please turn it in. But if you're not, you have until the end of the day today to get it finished and turned in. And even at the end of the hour today, there may be some time after your safety quiz for you to actually finish it. So if you're not quite done, I do need to move on to some other things, okay? But again, you'll have some time maybe at the end of the hour to finish it up. And if not, you just need to get it finished up and turned in before the end of the day today. Questions? All right. In your notes, ladies and gentlemen, we had these slides. You had slides 4, 5, and 6, ladies and gentlemen. Oops. Okay. And in there, we had some definitions and things for you. Okay. 4, 5, 6, 7, 8. We did not get to the terms on slide 8 yet. So please don't panic on those. We will get to those. These 3 terms will not be on your quiz on Friday. Precision, accuracy, and significant figures. Those are separate topics that we will talk about at some point in here. Okay? That we will get to. But what I do want to do is go back and talk about some of these terms in terms of the lab that we did. Now, again, I am going to ask you the definition of chemistry. I'm telling you that right now. Your quiz on Friday will be a mixture of free response, meaning you have to type in an answer, and multiple choice. Okay? And one of the questions I'm going to ask you is to define chemistry. The science of the study of matter, its structure, properties, composition, and the changes it undergoes. Okay? So that question will be on the test. I am going to ask you to define matter. In 2 words, what is matter? Has what and what?
Mass and space.
Well, correct. Mass and space. I will accept that. Volume is a little better term to use, but I'll accept mass and space. Anything that has mass takes up space. Has mass and volume. That's what matter is. Okay? All right. So again, that's going to be something that's going to be on your quiz. Name me something that is not matter.
Light.
Light.
Thoughts.
Thoughts. Gravity. Magnetism. Ideas, emotions, feelings, any type of energy, okay? Very few things aren't matter, but there are some examples that are not, okay? All right. This slide, I will be asking you about these definitions. Hypothesis, experiment, constant, and control, okay? I will be asking you about those definitions. Well, in your lab, you just wrote a possible hypothesis for your lab. Wait, did we do that with you guys? Did we write one? Is that one of the questions? Yes?
Hypothesis?
Yes.
Yes.
Okay, good. I'm sorry. Getting my couple classes confused here. Hypothesis, educated guess, if-then statement. Okay? Educated guess, if-then statement. So in your lab, you could have used something like, I'm just going back to my vocabulary right here, ladies and gentlemen, bringing it up so that we can talk about it. So again, a hypothesis is an educated guess in the form of an if-then statement. So if the temperature increases, the Alka-Seltzer will dissolve faster. That is a possible hypothesis. And again, the nice part about that hypothesis is you're telling me what is happening to the temperature. It's going up, it's going down, but you're also telling me then what happens to the other variable, how fast it will dissolve, okay? Constant is something that does not change or stays the same in the experiment. So constants in our experiment, ladies and gentlemen, the number of Alka-Seltzer we used, the amount of liquid we used. When we were comparing 7-Up to regular water, temperature was actually a constant in that part of the experiment, even though temperature was a variable when we were using the hot water and the cold water, okay? So it's something that does not change in the experiment, okay? So the timer, the person seeing how long it takes the Alka-Seltzer to dissolve, all of those could have been constants. Okay? Experiment is a carefully controlled series of observations. That is why all of my labs are in that 2-column format. Here's the procedure. Here's the step you do. Here is what happened because of it. Okay? Now, again, you don't always have to write down what happened. If the last step of the procedure is to clean up the lab, you don't have to put down an observation that says, well, I cleaned up the lab. Okay? No. You don't need that always. A control, ladies and gentlemen, is something you compare to in the experiment. What was the control in our experiment yesterday? Room temperature water. We said always go back and compare to that. Did the hot water get faster or colder compared to room temp? Did the cold water get faster or slower compared to the room temp? Okay? Something that you compare to in an experiment. All right. So an observation. Observations are information gathered using your senses or instruments. Okay? Either one, using your senses or using instruments, ladies and gentlemen. And now I will have some students once in a while go, well, Mr. Brand, how can you use an instrument without looking at it? True. So you're always using your senses, ladies and gentlemen. But again, to make a measurement, to get a number, you have to have an instrument. Okay? You cannot just make up a number unless it is something that we count, like the number of Alka-Seltzer. Okay? So there are two types of observations. Qualitative, meaning information that does not have numbers, things like the color of the liquid, things like the fact that the water was a liquid, the Alka-Seltzer was white, it had an odor, if you touched it, it felt grainy, things like that. Okay? What you see, what you feel, what you hear, what you smell, what you taste, using your senses. And then there's quantitative. Quantitative requires data. Quantitative is numbers, okay? And that is the only way it can be quantitative, is to have numbers. Here's the nice part about quantitative data. It is reproducible. What does that mean?
You can redo the experiment and get the same answers.
Or even this, if you do the experiment, and Jared does the experiment, and we take the same measurements, probably going to get similar numbers, okay? That is reproducible, okay? That is reproducible. Cynthia, can I pick on you for a second? I'm not really going to pick on you, but can I ask what color sweatshirt does Cynthia have on today? Tan? Khaki? Khaki? Tan? Beige? Apricot.
Apricot.
Finally, somebody who's not working out of the box of 64 crayons. Okay. How is it all of those colors? Thank you. We all have different perceptions, okay? I could ask you what color Leaf's sweatshirt is on the arms, and we might get burnt orange, orange. Somebody might say red. I don't know. Okay, whatever. You got brown the other day? Okay, yesterday would have been a good day to ask this question because I had on a weird color pants. They're kind of a greenish, dark color. Okay? Yeah, some people remember that. I got told that my outfit didn't match yesterday. I was hurt.
You look like
I was hurt. What?
You look like Ken.
Yesterday?
Yeah.
Really? Oh, man. I'm not wearing that outfit again. But I didn't think I looked that bad because normally if my outfit looks bad when I walk out of the bathroom in the morning, my wife will look at me and go, and I'll just turn around and go change. Okay, she did not do that to me yesterday, so I thought I was okay. Sorry, ladies and gentlemen.
I thought you wanted the
I didn't even notice that.
No, I did not want a Barbie themed outfit. But anyway, ladies, I do like my pink polo shirt. I just apparently shouldn't have worn it with those pants. But anyway, ladies and gentlemen, by the way, I had the pink polo long before Barbie came out as a movie. Okay, just so you know. Point being, when we look at Cynthia's shirt and we see beige, we see tan, we see apricot, we see khaki, okay? There is nothing wrong with any of those observations because they're what we see, okay? I had a father who was colorblind. He could not tell the difference between black and blue. So if we were getting dressed up to go out somewhere and he needed dress socks, he would call a kid into the room and go, are these black or blue? Because he had no idea, okay?
What if you just lied to him?
What's it?
What if you just lied to him?
It wouldn't have mattered because black and blue go with basically everything anyway.
Why would you get black and blue socks?
What's that?
I don't know.
I don't know. Don't ask me. I was a kid at the time, okay? Leave it be. It was starting to be a good story. You ruined it, Brindley. That's fine. No, it's okay. Point being, though, ladies and gentlemen, I'll give you another example. How many of you have ever gone to like Kohl's or a department store and smelled some perfumes there and gone, oh my God, I wouldn't spray that on my dog? Right? Why are they selling it then?
For people that like that smell.
Thank you. There are some people who like that smell. And it's, again, we could say it's weird, but it's a matter of your personal perspective. No different than, when I was a kid, every once in a while you get invited over to a friend's house and they'd be like, oh, you want some Kool-Aid? And I'm like, yeah, I'd love some Kool-Aid. And you ever have that cheap friend who, when they made Kool-Aid, their parents put the flavoring in there but no sugar? So it's like drinking colored water. And you're like, oh, and they're like, oh, this is great. Mom made this extra sweet this time. What? Like, come on. I don't think she put a tablespoonful of sugar in there. Okay? But the point is, again, you may go eat a meal or invited over to a friend's house and eat a meal and be like, oh my God, I cannot eat this. And they may be like, isn't this great? Isn't this wonderful? We all have different tastes. So when it comes to qualitative observation, sometimes that gets in the way. Someone will smell a scent and be like, oh my God, it was the most putrid scent I have ever smelled. And someone will be like, man, I thought it was like roses. And it's okay because we're still detecting an odor. But that's what we mean when we say reproducible. We ask 3 people the color of Cynthia's shirt, I get 3 different answers. That's not reproducible. But I ask 3 people to measure the height of the door, I should get numbers that are very close to each other, assuming we're using the same units and the same instrument. Okay? So that's the power of quantitative data. All right. So again, in your lab, the number of Alka-Seltzer we used, the amount of liquid we used, the time that it took, all those were quantitative observations. Okay? A variable, ladies and gentlemen, is anything that changes. Anything that changes in the lab. So the time changed, the temperature of the water changed, the type of liquid changed. Okay? Those were variables in the lab. Then there were the variables. Oh, by the way, in a good experiment, we try to limit the variables. We try to limit the variables. So we don't compare cold soda to room temperature water. Wouldn't be fair to do that because you're putting in 2 variables. The soda's cold and it's not the same type of liquid. So we try to limit our variables to see their effects. There is the independent variable, the variable that you, the experimenter, control. Okay? Also, independent variable, always measured first, ladies and gentlemen. It is the variable that the experimenter has control over, and it is the variable that you would measure first. The dependent variable then changes afterwards because of it. Okay? The dependent variable would not, or changes because of the independent variable. Okay? So, really? My sinks are really good. You got to crank them down to get them so they don't drip. What determines how much water comes out of the sink? And? Why?
You're the one that controls how much you turn.
And I control how long I let it run. Right? So the independent variable is how long I turn the faucet on for, how high I turn it on, or how open I turn it, whatever the case may be, right? The dependent variable is what?
How much water comes out?
How much water comes out. Okay? So I determine how fast it's running. I determine how long it runs for. How much water comes out is determined by that. Independent and dependent variable. Questions, ladies and gentlemen? Okay. Now, one of the things that we're going to talk a lot about in here are relationships. Okay? And there are 2 basic kinds in science. There's a direct relationship and there is an inverse relationship. In a direct relationship, if one variable changes, goes up or down, the other goes in the same direction. So, the longer I turn on the water for, what happens to the amount of water?
More water comes out.
What kind of relationship is that? That's a direct relationship. Both are going up. Both are increasing. Yeah. Okay? Both are going up. Both are increasing. Okay? It doesn't matter which way they're going. You can talk about them decreasing. You can talk about them increasing. But they're both going in the same direction. One goes up. The other goes up. One goes down. The other goes down. The other type of relationship, ladies and gentlemen, by the way, if you were to graph this, the line on the graph goes up. Now, I don't care how it goes up. I don't care if it's straight. I don't care if it's curved. The line is going up, though. Okay? Anytime the line on a graph is going up, it represents a direct relationship. Okay? An inverse relationship. One variable is increasing, the other is decreasing. Okay? So in December, as we go from the first day to the second day to the third day, the days are increasing, correct? What's probably going to happen to our temperature?
Colder.
It's going to get colder. So therefore, that is an inverse relationship. As the days in the month get higher, the temperature gets colder. Okay? That is an inverse relationship. One variable is going up, one variable is going down. Okay? On a graph, the line would go down. Again, might go down straight, might be fairly straight and then fall off, might drop down dramatically. The line is going down though. Somehow the line is going down, ladies and gentlemen. Okay? That is what's happening there. And in a constant relationship, now you can be constant and direct, you can be constant and inverse. What does constant mean again?
Ongoing.
Well, what did a constant mean in our vocabulary?
Not changing.
Not changing. So in a relationship, it is possible that something is staying constant. Something is not changing. That is a relationship where the variables change at the same rate so that your line ends up being straight. So if you ever have a straight line on a graph, it is a constant relationship. Now, if that line happens to also be going up, it is a constant and a direct. If that line is straight and going down, it is a constant and an inverse. Okay? So what is the opposite of a constant relationship? It is a non-constant relationship, and it is where the variables change at different rates. And what that means, ladies and gentlemen, is you're going to have a curved line on a graph. Okay? A curved line on a graph. We will get into talking about that a lot more in our next unit. Questions? All right, that's it for that part of the class. Questions on terminology? Okay, what's that? And it's on that vocabulary that we were just going over. But right now, what we're going to do is we're going to take our safety quiz. Okay? Now, again, the safety quiz is 15 questions. It is multiple choice. When you are done with the quiz, you can literally go and view your score. And if you have less than 15 out of 15, you can go back into your quiz and you can change any answer you want. Okay? Now, I don't believe it's going to tell you which one you got wrong. You got to figure that one out on your own. Okay? But you can go back and you can change any answer until you get to a score of 15 out of 15. Now, please think about this. Say you get a 14 out of 15 and you go back into your quiz. You go to problem 6 and you change your answer. What are the 3 things that can happen to your score?
Grade can stay the same, go down, or go up.
Okay, so what does it mean if your grade stays the same? You went back to problem number 6, you changed your answer, and your grade stayed the same.
It was wrong and you got it wrong again.
Mm-hmm.
You got the right question, but you still picked the wrong answer. Yes. What happens if your grade goes down?
You already had the right answer on the question.
Okay. So the reason I am telling you this is if you have a couple wrong and you're not sure which ones you got wrong, you may want to attack them one at a time. Okay? Because if you change 2 of them, now it isn't quite so easy. Now we're talking about an experiment where we change 2 variables and okay, your score stayed the same, and maybe it stayed the same because one that was right you made wrong and one that was wrong you made right. Okay? Could have happened that way. Okay? Or both of them that were wrong, you're still wrong. The best thing to do is go back and change them one at a time. Okay? If you're really, really, really struggling, come up and ask me. I'll take a look at your results and point you in the right direction of which one you might need to check out. Okay? So in Google Classroom right now, ladies and gentlemen, I'm going to post the safety quiz for you. Again, you have to get 100% on it, ladies and gentlemen. I need to find it. Lab safety quiz. Okay? You have to get 100%. If you don't, you need to go back and you need to take it again. Drive. Sorry, I should have had this ready. Yes, go ahead. Oh, I'm sorry. I thought somebody asked a question.
Oh, yes. Is this what we're going to do for the rest of the class?
This is what we're going to do for a little while. Yes. The rest of the class, I'm not quite sure of. Oh, where did my safety quiz go? All right, hang on a second, ladies and gentlemen. Sorry, I should have had this ready to go. I don't. That is my fault. That's not it. That's not it. That's not it. You don't want to take the physical science final exam, do you?
No, not really.
I didn't think so. I didn't think so. My drive. All right, let me double check something real quick here before I post it for you. All right. All right, that is ready to go. Assign. Okay, so I just assigned the safety quiz to you, ladies and gentlemen. It is in Google Classroom, right there. Again, when you click on it, ladies and gentlemen, and do it, okay, you answer. Do I still have that in there? I do. First period chemistry, that's you guys. Again, when you are all done, ladies and gentlemen, and you hit submit, it will take you and it will ask you if you want to view your score, if you want to edit your responses. Please go ahead and check your score, and then you can edit your responses if you need to. I hope I have everything set correctly for you.
It is show.
It's like not there.
It's not there.
It's not
Not.
there. Did you refresh your screen?
Yeah, a
Yeah.
few times.
But it did not.
A few times.
Classroom.
Oh.
That would be why. Why are you guys not conceptual chemistry hour 1 through 4? Oh my gosh. No wonder why. I'll bet you that's why it's not there. I have it set in here. Oh, look at there, right at the top. My gosh. It's always good to show a class when you're inept at things once in a while, ladies and gentlemen. There you go. Sorry about that.
It's there.
Hey, what do you know? When you actually put it there, it actually shows up.
It's there.
How do you like that?
How come you have to take this quiz for every science class?
Because it's a district requirement. I have to show that I have taught you safety and that you have understood safety.